Hello, welcome to everyone in this video. This is our lecture number 47. Already 46 lectures are covered to solve the problem of the book, that is Electricity and Magnetism by Basudev Ghosh. Okay, for this book, this is actually part 28, and the rest of the lecture actually covered the solution of the problem that is in DJ Griffith, Electrodynamics by DJ Griffith. Okay, so if you want to watch the previous lectures, you can go through the description box, link given in there. So in this lecture we want to discuss about the question that is the 51 to 57 of chapter 8, that is actually magnetostatics, that consists of the magnetostatics. We want to discuss about this question number 51 to 57, right? So let's start with question number 51, which says a charged particle moves in uniform velocity v, which is 4 I cap, in the region where electric field is 20 j cap volt per meter and the magnetic field b0 k cap weber per meter square. Determine b0 such that velocity of the particle remain constant. So for constant velocity of the particle, that means net force on this particle must be 0. So there is two force, that is magnetic force and the electric force. So these two are equal and opposite, must be such that they are cancel out to each other. So q v cross b equals to minus qe. So just put this value, q cancel out, v is 4 I cap and b is b0 k cap, whereas electric field is 20 j cap. Just I can this will gives you minus j cap. So these two are cancel out, we will get this. So I think there is a missing, there is a minus. So I cross k will gives you minus j cap, these two are cancel out, then 4 b0 equal to 20. So the b0 value is 5 weber per meter square. Clear? I think clear. If there is any doubt, you must comment in the comment box. Go to the next one, that is find the force per unit length between two long parallel wire carrying each current 1 ampere. These two are carrying conductor are parallel, so placed at so the magnetic field due to I2 magnetic field at this point due to I1 is like that, in the theta cap, in the vector form if you want, theta cap. So the force will be I2 dl into this magnetic field. So force per unit length, so this will dl will be 1. So this is mu 0 I1 I2 by 2 pi d. Clear? So the force per unit length between these two, when they are in the parallel, they are in the attractive. This actually force will be attractive, and the value will be like that. Mu 0 is 4 pi 10 to the minus 7. So there is a 2 into 10 to the minus 7. I1 I2 both is 1 ampere and the distance will be 10 centimeters. So in the meter this will be multiplied by minus 2. So finally we will get this Newton per meter. Sorry, this will be this Newton per meter force per unit length. Go to the next one, which says how much force would be act on 10 centimeter long wire carrying a current 10 ampere placed at angle 30 degree or direction uniform magnetic field is. So you know force is I L cross B. So I L be sin theta, I is 10 ampere, L is 10 centimeter. So in meter 10 to the minus 2 multiply, B is 1 Weber per meter square and 30 angle is 30 degree. So 10 10, so these are cancel out and sin 30 is half. So finally we got 0.5 Newton, right? Go to the next one. Consider three coplanar straight equally spaced. So these are the coplanar line which are equally spaced, long thin parallel wire each carrying current I in the same direction. Outer two wire are held fixed and the middle wire is given a small displacement in the same plane towards one of the outer wire, so that the motion of the middle wire will give the simple harmonic with the time period like that. So when we displace this middle wire, then this oscillate and the oscillating period will be like that, right? So you think that is for if we displaced at a distance x from this mean position, then what will be the distance from wire 1 is d plus x. So the corresponding force per unit length will be mu 0 I square 2 pi d plus x. Just use this formula, right? So mu 0 I1 I2 by 2 pi d. Here this I1 I2 are same, that's why I retain I square, and the distance will be d plus x. So finally we got this, the force on this wire, this middle wire, due to wire 1, and similarly for due to wire 2, this will be d minus x. So the net force will be, this will be attractive, this will be attractive, so net force will be minus division, if we minus these two force, then you will be get these things, and d square minus x square can be written as d square because this is very much greater than 2x. So finally we got this equation, and you know this is the general equation for wave oscillating. So this is omega square, where the omega will be like that. So the time period is 2 pi by omega. Put this value of omega, you will be get this time period. Clear? Very simple. Go to the next one. Suppose that Earth magnetic field is caused by a small current loop located at the center of the Earth. That means there is a small current loop at the center of the Earth. Due to this current loop, there will be arises magnetic field of 10 micro Tesla of the radius of the Earth taken as 6,000 kilometer. Find the magnetic moment in this small loop. So from the previous, I think question number 29, question number 29 of this book, we already discussed about this thing in details. Just think this is a current loop with the distance x, and this radius will be a. Then the magnetic field will be like that, mu 0 I by 2 I square plus square by square plus x square whole to the power 3 by 2. Then here you can see the when this x is very much greater than a, though this can be written as x cube. So this will be like that, and from where will we get the value of I, and after that you know the magnetic moment is nothing but Ia. This is the v0, so this is the Ia. So put this value of I, and a is pi a square, so just rearranging you will be get this expression. And actually this proof actually happen in this problem. Now just put this value in this equation, that is for 2 pi rq is rq, r is this rq v0. So 2 pi rq, r is 3000 kilometer, kilometer to meter, and then v0 is micro Tesla to Tesla, and mu 0 is 4 pi 10 to the minus 7. Just calculate, you will be get this answer. But this is not matches with this one because I don't know. You just check, and if there is any fault in my calculation, you must comment in the comment box, right? Go to the next one. Suppose Lorentz force on the particle of charge q and mass m is like that. This is the Lorentz force, where electric field related to this gradient of phi is the potential, time dependent electric field, and so the energy will be constant. You know, so force is written here. So F is nothing but m dv dt. So this will be arranged in form, and then the dot this v in the both side, and this gives you 0. Just rearranging in, and this. So just taking this m, and this is nothing but half mv square derivative, and this can be written as q5 because v dot e is nothing but e is minus e is grad phi. So v and this dot product, so this is vx del phi del x, vy del phi del y, vz del phi del, and vx is nothing but dx dt, vy is nothing but dy dt, and vz nothing but dz dt. So this thing is nothing but d phi dt. So this is nothing but d phi dt, and since this is a phi independent time independent, so this can be written as d phi dt. So if we put this as a d phi dt, so this will be 0. So derivative is 0, so this term will be constant. I think clear. If there is any doubt, it must comment in the comment box. Go to the next one. This is a in different type of question. You can see here a point particle of mass m and magnetic dipole moment m1. This is dipole moment m1, mass m, moves in circular orbital radius r, fixed magnetic dipole m2 located at the center. The vector m2 and m1 antiparallel to each other, perpendicular to the plane of orbit, so that these two are antiparallel and they are perpendicular to the plane of orbit, so that speed of the orbit will be like that. So magnetic field on m1 due to m2 will be like that, and force on m1 will be magnetic field in, you know, magnetic field, and this magnetic moment m1. So force will be like that. After getting force, this force is nothing but supply of the centripetal force, that is mv square by r. So equating this string, you will be get the value of velocity, expression of the velocity will be got, right? I think clear about all the question we discuss in this video. If there is any doubt, you must comment in the comment box. And at this question we did not matches answer, if you will be get the actual answer, if there is any calculation error, you must comment in the comment box. Clear? This is all about me, and this is my contact details. You can join with my telegram channel, and this is my uh, another contact details actually, and this is my youtube channel details. Go to this channel, we get the others video regarding physics, some mathematics, and some computer exam reasoning part also. Like this session if you learn from this video, and share this video to your friends so that he or she also get benefit from this video. Subscribe this channel if you new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get the notification when we uploaded the next video. So thank you for everything, for listening. We will meet in the next video as soon as possible. Take care.